For the longest time, designing a computer chip has been one of the most exclusive, expensive, and frankly closed off fields in all of technology. It was like a club with a very, very short guest list. But what if all of that was about to change? What if the keys to that kingdom were suddenly available to, well, everyone? Let's dive into how that's happening as we speak. And this is really the big question, isn't it? Just imagine a student in their dorm room, a hobbyist tinkering in their garage, or a tiny startup with a massive idea. All for the longest time, designing a computer chip has been one of the most exclusive, expensive, and frankly closed off fields in all of technology. It was like a club with a very, very short guest list. But what if all of that was about to change? What if the keys to that kingdom were suddenly available to, well, everyone? Let's dive into how that's happening as we speak. And this is really the big question, isn't it? Just imagine a student in their dorm room, a hobbyist tinkering in their garage, or a tiny startup with a massive idea. All of them having the power to create their own custom silicon without needing a $1 billion budget. It honestly sounds like something straight out of science fiction, but it is fast becoming our reality. And look, this isn't just some hypothetical what-if scenario. This revolution has a real starting point, a specific moment in time when the impossible suddenly became, well, possible. So that moment, it was back in 2020. Google, working with Fabless and a foundry called Skywater, did something nobody saw coming. They launched a free shuttle program. Now, this completely shattered the biggest barrier of all, the absolutely astronomical cost of actually manufacturing a chip. For the very first time, you could take your open source design and get it turned into a real physical piece of silicon for free. This was the spark that lit the whole fire. And wow, from that one spark, a whole fire started. What began as a single program quickly grew into a complete, thriving ecosystem of tools, people, and projects that has now kind of surprisingly reached a real level of maturity. What's so cool about this is that it shows this isn't just about software and code. It's powered by this amazing global community of thousands of people. The open source Silicon Slack channel is like the digital town square where students, seasoned experts, and curious hobbyists all come together to collaborate. And then you have projects like Tiny Tapeout that make it even easier to get started by letting a bunch of people share the cost of a single chip run. It's a genuine movement. Okay, and this next part is really important. This quote isn't just some marketing hype. It marks a huge milestone. What it means is that the collection of open source tools, the Flow, can now handle the entire digital design process for a custom chip, an ASIC, from the very beginning to the very end. It's not just an experiment anymore. In fact, there's an industry term for this, tape-out hardened. It basically means the process is reliable and proven because it's been used to successfully manufacture real, complicated chips. This is the proof of maturity we're talking about. Designs like the Strive RISC-V system on a chip, which is pretty much a full computer on a single chip, show that this stuff actually works. So how does it all work? Well, this whole incredibly complex process can be boiled down into three main stages. First, you've got synthesis, which is like creating the master blueprint for your chip. That's handled by a tool called Yosis. Then comes placement and routing, where tools from OpenRoad meticulously arrange all the millions of tiny components. And finally, you have sign-off and verification, which is like the final rigorous quality inspection. The whole shebang, what used to be a multi-million-dollar toolchain, is now available to anyone. Okay, so the promise is incredible. The ecosystem is mature. It works. But, and this is a big but, this brings us to the most important question of all, the ultimate reality check. Look, it's one thing to say you can make a chip. It's a whole other ballgame to ask if that chip is actually any good. How does this open source flow really stack up against the established commercial giants when it comes down to the quality of the final product? All right, let's just rip the Band-Aid off and look at the hard data from a direct comparison. First up, physical area. In chip design, smaller is always better. The chip designed with open source tools, it was 53% larger than the one made with commercial tools. That is a significant difference in a world where every millimeter counts. And if you thought that was a big number, wait till you see the power consumption. I mean, from our phones to massive data centers, efficiency is everything. The open source design used 118% more power. That's more than double its commercial counterpart. Ouch. So yeah, this chart really lays it all out, doesn't it? When we're talking about digital design, and you've got these really strict targets for how small your chip needs to be or how little power it can use, the conclusion is pretty clear. The highly optimized commercial flows still have a major advantage. So you're probably asking, why the huge gap? Well, this diagram explains it perfectly. Commercial tools are like a straight automated highway. You put your design in and you get a highly optimized result out. The open source path is, well, it's more like a winding country road. It'll get you to the destination for sure, but it takes a lot more manual tuning and iteration from you, the designer, to get that top-tier performance. And the same kind of trade-off pops up in the world of analog design too. Is it feasible with open source? Absolutely. But it just doesn't have that sophisticated, constraint-driven automation you get with commercial tools, which means the designer has to do a lot more of the heavy lifting to get things just right. But, and this is important, it is not a one-sided story. This is where things get really interesting. In verification, the whole process of making sure your design is actually correct, open source has some serious firepower. The simulator, Verilator, is often faster than the commercial options. And tools like Symbiosis give you these powerful formal verification methods that are mathematically rigorous. The main gap right now is the lack of big libraries of pre-built reusable verification components. So when we put it all together, what's the final verdict? It's really not about which one is better. It's about understanding the trade-offs and knowing when to use the right tool for the right job. This scorecard sums it up pretty nicely. For that raw digital performance, power and area, commercial tools are still the leader, thanks to their superior automation. For analog design, open source is totally feasible, but it's going to require more manual effort. And for verification, open source has best-in-class speed and powerful formal methods, while commercial tools offer more complete, all-in-one environments. So what's the big takeaway for you? The open source flow is an absolute game changer for prototyping, for education, and for research projects where getting access is more important than squeezing out every last drop of performance. But you want to be a little cautious when you're facing those really strict power and area targets, or if you need to integrate a lot of complex commercial components. But okay, even with those trade-offs, here's the most exciting part, the truly incredible stuff that people are building with these tools right now. This whole movement has just unlocked this amazing wave of innovation. Let's take a look at a few quick examples. For example, check this out. People are building sophisticated peripherals like this micro-coded USB device. This is a seriously complex project that, just a handful of years ago, would have been completely impossible for an individual designer to even attempt. And then you've got people designing high-frequency radios like this 5 GHz satellite transceiver, really pushing the boundaries of what's possible in the analog world using open tools. It doesn't stop there. Some folks are even building entire processors from scratch, like this complete RISC-V CPU. I mean, the very heart of a computer, now designable by anyone. That's wild. And creators are designing custom hardware for the most cutting-edge stuff out there, including specialized AI accelerators. All of this is happening right now, out in the open, all thanks to this revolution. So what's the bottom line here? The open source silicon movement has successfully democratized chip design, period. And while some performance gaps still exist, the tools are mature, they're powerful, and most importantly, they are accessible. And it really makes you wonder, with all these barriers torn down, the next great chip designer truly could be anywhere. The revolution has only just begun.